Greetings. My name is Daniel Matanga.
And my name is Aaron Zayed.
We are students from Radish International School, Maputo, Mozambique, and our project is about the protective and antioxidant effects of sulforaphane and germinating radicase treated with hydrogen peroxide. Free radical chain reactions result when atoms containing unpaired electrons bound by molecules and alter their biological functions, contributing to the progression of diseases such as atherosclerosis, cancer, and diabetes. Antioxidants such as vitamin E and sulforaphane peel effectively neutralize the free radicals and prevent cellular damage. This present study is conducted to determine the relative effectiveness of sulforaphane against free radicals generated by hydrogen peroxide compared with an antioxidant vitamin E. In this experiment, H2O2 is a source of free radicals, and germinating radicales are modeled to test the protective antioxidant effects of free radicals.
Free radicals are atoms or molecules that are hazardous to cell health and are the root cause to many degenerative diseases. Free radicals also have an unpaired electron with their outer shell that makes them highly reactive. Because of this, it results in a cascade in their chain reactions that may alter their biological function, eventually leading to cell degeneration or death. Some of the sources of free radicals come from burned or smoked food, pre-manufactured good, ionized radiation, and many others by the same machine type exhaust. Diseases that can come from the free radicals are atherosclerosis, senile dementia, diabetes, asthma, inflammatory joint disease, degenerative eye disease, by damaging the genetic material within the cells. Nevertheless, naturally occurring compounds in our diet are called antioxidants. Antioxidants also play a very important role in neutralizing the free radicals. Antioxidant molecules vary in their properties to counteract free radicals, and one of the most abundant and lipophilic radical scavenging agents of sulforaphane that is found in vivo are free radicals. Recent studies demonstrate that phytochemical ingredients can be found in cruciferous vegetables, such as broccoli, sprouts, and cabbages, that can be cytoprotective and act as an antioxidant molecules and improve the activation of very antioxidant molecules. However, the relative effectiveness of this study is still unknown.
Materials and methods, solution preparations and treatment groups set up. The solutions for each of the experimental group were prepared using a graduated cylinder. For this experiment, there were 6 petri dishes with 10 radicase in each, with a different 10 ml treatment added to each one, as seen in figure 1. First, coffee filter discs were placed in each petri dish at the bottom to produce a foundation for seed germination to occur. 10 ml of distilled water was added to the control group, and 10 ml of 1% H2O2 diluted from 3% H2 was added to the comparative control group. Next, the contents of a broccoli extract rich with sulforaphane peel were added to 10 ml of water, stirred well, filtered, and added to the petri dish labeled as sulforaphane. This step was repeated for the vitamin E peel, and the solution was added to the vitamin E petri dish. The concentration of the sulforaphane related treatment was 400 micrograms per 10 ml of its corresponding solution, and is comparable to the 400 IU or 20,000 micrograms per 10 ml of its corresponding solution, as both are the recommended daily dose as established by dietary guidelines.
After 3 weeks of incubating radicase in the presence of 1% of H2O2, tests were then recorded and analyzed. A representative picture of germinating radicase with different experiments shown in figure 1 and table 1 display the summary of radicase germination obtained with 4 different individual experiments that were approved by a one-way ANOVA test that gave us the results of P less than 0.05.
This study was designed to determine the effectiveness of sulforaphane in preventing the effects of free radicals on germinating radicase. Our experimental results support that sulforaphane-rich broccoli extract is more effective in neutralizing the effects of free radicals generated by hydrogen peroxide when compared to the antioxidant vitamin E. The results of the present study show that sulforaphane-rich broccoli extract can act as an effective antioxidant and suggest that this extract is more potent than vitamin E in countering the free radical effects. In effect, this study is helpful to further expand on existing researches regarding sulforaphane and its potential and uses as an endogenous antioxidant. Thank you for the attention, listeners.